Okay, so dear students, in this video we are going to study the leftover part of dielectric and polarization, and we'll start a new topic, that is capacitor. So firstly, dielectric and polarization, leftover part we are going to study. Okay, so what we saw earlier was, if I have either polar or non-polar, polar or non-polar dielectrics placed in an external electric field, this way, placed in an external electric field, gets polarized. So if I have a either polar or non-polar dielectric, when placed in an external electric field, they get polarized. But they polarized differently. For example, in polar dielectrics, polarization occurs due to the alignment of the already available molecular dipole moments. But in case of non-polar dielectrics, there is a stretching effect of the molecules such that it gets polarized and will have non-zero net dipole moment. So in both the cases, what will happen? We will get net dipole moment P. In the both cases, we will get net dipole moment P. And all the molecules will align or stretch according to the direction of the electric field, this way. Negative charge will move against the field and positive charge will move along the field. Okay, negative positive, negative positive, negative positive, negative positive. So this is how they gets polarized, and individual dipole moments of the molecules align along the same direction. Hence, this dielectric will have non-zero net dipole moment, that is P. So if you see closely in this polarized dielectric, what we see is, so I'm just taking the polarized dielectric here. So it has polarized this way: negative positive, negative positive, negative positive, negative positive, negative positive, okay, negative positive, negative positive, negative positive, negative positive, negative positive, negative positive. Now, if you see closely, one of the positive charge and one of the negative charge of this dielectric, like individual molecule, are very close to one another. Again, this positive and this negative charges of the individual molecules are very close to one another. Positive and negative charge of this molecules, again positive and negative charge, positive and negative charge, positive and negative charge of this and this, this and this, this and this, and again positive and negative of these two molecules, these two molecules, these two molecules perfectly cancel one another. Okay, so this positive and negative will cancel, this positive and negative will cancel each other's effect, this positive negative. So all the charges which are inside the dielectric are neutralizing each other. So the only charges left are along the surface, this end of the dielectric. So your your polarized dielectric will look like something like this. Polarized dielectric will look like polarized dielectric will look like something like this. So all the positive negative charges are accumulated on this direction, and all the positive charges are accumulated on this direction, and all the charges inside the dielectrics gets neutralized. Okay, so this is your polarized dielectric. Polarized dielectric. This is your polarized dielectric, and here there will be an electric field associated from positive to negative charges, and we call it induced electric field. And there is an external electric field which is a polarizing electric field outside. So there are two electric fields basically in polarized dielectric. One, external electric field, which polarizes the dielectric by separating the charges, and there will be an induced electric field which is directed from the positive to the negative against the external electric field. So this is your external electric field in this direction, and there is a induced electric field in this direction. So net electric field inside the dielectric will be net electric field inside the dielectric will be equals to E external plus E induced. Actually, I have written plus here, but they are opposite in direction, so their magnitude will get subtracted. So the net electric field will be decided by the magnitude of the external and induced electric field. Okay, so this is all about dielectric and polarization. So now we are going to start a new topic today, and those are capacitors, that is capacitors. So capacitors are nothing but is an arrangement of two conductors. For example, if I have one conductor this way, and let us take another conductor this way. These are conductors. This is also conductor. And if conductor are separated by some distance d, these two conductors are separated by some distance d, and what we will do? We will charge each of the conductor with opposite polarity. For example, we will charge this conductor positively this way, with Q charge, and we will charge this conductor with opposite polarity, that is minus Q charge. Okay, so when we charge this one of the plate, like one of the conductor positively, then it will gain a positive potential, because potential of this conductor 1, let us take this is conductor 1 and this is conductor 2. So potential of conductor 1 will be positive, Q divided by 4 pi epsilon naught R, because charge is positive, potential will be positive, and the potential of conductor 2 will be negative with minus q divided by 4 pi epsilon naught r, because at the surface and at each point on the conductor the potential remains constant, we have studied. So at surface also, at each point inside the conductor the value of the potential will remains constant, and for this conductor also at each point on the surface and even on the point inside the value of the potential will be this much, which is positive, and here it is negative. So what we see here is, when you increase the value of the charge, when you increase the value, okay, one more thing, now it has a positive potential and it has a negative potential. Okay, now we can actually calculate the potential difference between these two conductors. So what is the potential difference between the conductors? So potential difference between the conductors will be V, so which will be equals to V1 minus V2. So it is a difference between the two potentials. So it is V1 minus V2, and if we see closely, V1 is positive, so this is positive quantity, this is positive quantity, minus V2 is negative quantity, and V2 is negative quantity. So what we will see here is negative will be, like, we can write this way, it as a this way, your V1 is positive and V2 is your negative actually. So V2 is your negative, so minus minus will be plus, so it will be V1 plus V2. So your actual potential difference will be the sum of the two potentials. Okay, and this individual potentials depend upon the charge contained in them. So if Q is more, V1 will be more. If minus Q will be more, V2 will be more. And if V1 and V2 will be more, V will be more. That means this charge is directly proportional to the potential V, because Q increases V1, even minus Q increases V2. So if V1, V2 are both large, then your V will be large. So this charge on the capacitor Q will be directly proportional to V, potential difference between the conductor. If charge will be more, potential difference V will be more. So if we remove this proportionality with equality, we will add one constant C. So that constant C is known as capacitance of this, it is known as capacitor. So this arrangement is known as capacitor. This arrangement is known as capacitor, because, like, what arrangement? Two charged conductor separated by some distance d is known as capacitor, and this C will be the capacitance of the capacitor. And alternatively, you can write this equation as C is equals to Q by V. C is equals to Q by V, and your C depends on size of the capacitor, and this distance between them depends on size, distance between the conductors, and nature of medium between the conductors. So this C also depend upon the what medium is inside the conductor. So this medium, if it is vacuum, then your C will be different. If it will be a dielectric, then your C will be different. So if this C, capacitance of this capacitor depends upon the size of the capacitor, the distance between the capacitor and the medium separating the two conductors. So I think this is it for today. So we will going to study more about capacitor in the later section. Thank you.